Hi guys, this is Calc video 3-3. See your checklist for when to watch. Today we're doing these things called implicit differentiation drills. It's just working us up to something bigger. Now down below, in each expression below, y is a function of x. So y could be something super complicated, like y could be sine of x, y could be natural log of x, y could be x squared plus 5x minus 7. We don't know what it is, but we do know that y depends on x. Y is some function of x. So it says here, differentiate each expression with respect to x. Okay, so so I boxed that up because what I mean here is that we want d blank dx. Okay, this means the derivative of something with respect to x. So d blank over dx means the derivative of whatever's in here with respect to x. It's another way of, it's just another notation for derivatives. Okay, so here is the expression, and you'll get the hang of this. So we have 2y as an expression, and we want the derivative of 2y with respect to x. Okay? Yeah. Okay, I think that notation is fine. It's a type of Leibniz notation. All right, so we've got to do an inside-outside chart. So inside-outside. Now, the inside function is y. The outside function is 2 blank. So the derivative of y with respect to x is just dy dx. And the derivative of the outside, if you have 2 times blank, the derivative is just 2. So the derivative here is just 2 dy dx or 2y prime. Guys, dy dx and y prime are the same thing. All right, they are the same exact thing. Okay, so you're going to get used to this. Okay, so now with this next expression, so we want the derivative. A lot of times they'll go like this. They'll go d dx 5y to the 4th, something like that. Okay, so these two things are kind of like the same things. All right, so we're going to do an inside-outside chart. Inside-outside. The inside function is y. We don't know what it is, but it's something that could be expressed in terms of x. And then the outside function is 5 blank to the 4th. The derivative of the inside function is dy dx. The derivative of the outside function, you got to use power rule, so it's 20 blank to the 3rd. And what goes back inside, whatever used to be here, which was a y. So the derivative is 20y to the 3rd dy dx or 20y to the 3rd y prime. Okay, Leibniz notation, prime notation. And sometimes Leibniz notation is preferable. You'll see in the future when. All right, now we're going to do this one. Now, this is cosine of y to the 3rd. If it meant that the whole cosine function was being cubed, the 3 would be in between, like right up there. So what we want is the derivative with respect to x of cosine of y to the 3rd, where y is some function of x. So inside, outside. Inside is actually, we're going to have 2 insides here. Because y is the innermost function, but what's happening to y, it's being cubed. So y is inside of blank to the 3rd. And then what's happening to this stuff, it's inside of cosine of blank. So the derivative of y is dy dx. The derivative of this function is 3 blank to the second, but what goes back is what used to be in there. So this blank is the same as that blank. What used to be in this blank is y, so it's got to go back in there. And then the derivative of cosine is negative sine of blank. Now what used to be in this blank here is blank to the third, but what used to be inside of there is y, so really like y to the third is going back in. So the derivative is negative, I'll just rearrange things a little, negative 3 y squared sine of y to the third dy dx. That's in Leibniz notation, or negative 3y squared sine of y to the third y prime. All right, guys, so there's that. I will talk to you soon. Bye-bye.